Healthy Crop, a Danish agricultural technology firm, has developed an innovative biological solution to crop protection. Their impactful contribution to sustainable farming secured them second place in this year's Global Innovation Showdown. Pernille, welcome. Thanks for sitting down with me.
Thank you for having me, Marcel.
Pernille, as the CEO of Healthy Crop, what inspired your transition into the agri-biotech startup landscape, and how has your background influenced your vision for the company?
Yeah, so my transition into to agri-biotech has been, well, I would say it has been shaped by a combination of scientific curiosity and a drive to create a real-world impact. So as you know, I hold a PhD in molecular plant biology, and after that I pursued a business degree from Copenhagen Business School. And I started my career in research, moved into leadership, where I had various positions in some large Danish corporations. And I think the experience from kind of the big companies, that gave me both a technical foundation and a strategic and a very commercial perspective. But over time, so I spent, 15 years in big companies here in Denmark. And over time, I quite fast realized that my passion lies in building something from the ground, building something meaningful. So when I had the opportunity of leading Healthy Crop, I felt that it was a natural fit. It combined my scientific knowledge and my curiosity with my business background. And also I believe that innovation is one of the keys if we want to change the way that we produce food. I think we need new innovations if we want to fulfill the targets that we have.
Absolutely, fully agree. I think we need all the innovations that are available to tackle and mitigate the enormous and unprecedented challenges that we have ahead of us as a planet. So let me ask you this. Your company, Healthy Crop, is developing fungal resistance. Can you explain a bit more about what is the mechanism that leads to the fungal resistance, and how is this approach different from traditional fungicide applications?
Yes, so at the very core of our technology is a natural plant enzyme called Nepentacin. And we originally discovered this in barley. Nepentacin is a protease, so it's an enzyme that breaks down other proteins, including the enzymes that the fungus use to degrade the plant cell. So the mechanism behind what you have to envision is if you have a normal field with the normal crops, then you have a fungus landing on the crop. Once settled, it will secrete enzymes into the plant cell and degrade the plant cell to free up nutrients. The fungus needs these nutrients in order to grow and multiply, but this will eventually kill the plant. So what we do is that we overexpress Nepentacin, so we make the plant produce more of Nepentacin, so it's an enzyme that's already there. We just boost the expression, so we boost the production, you can say. And what now happens is that you still have the fungus landing on the crop, and the fungus will still secrete a lot of enzymes into the plant cell. But now the plant cell has Nepentacin, which is protease, and it will degrade all these incoming enzymes from the fungus. And that means that the nutrients will not be released, and therefore the fungus will starve. And that means that the crop will have inherent resistance, you can say. So it's a genetic trait, so it's inherited throughout generations. So you don't have to spray, you don't have to apply anything. It's already inherited in the genetics of the crop. And what is very different with our way of dealing with fungal infections compared to spraying with fungicides is, of course, that it is inherent resistance. So it's not something you have to spray. That means that it's very durable. Also, if you compare it to kind of the classical R-gene way of getting resistance, then if you change an R-gene so it's no longer compatible with the fungus or with the fungus enzymes or proteins, then the fungus can over time mutate, so it will circumvent the resistance. But with our mechanism, because it's based on proteolysis, so degradation of the enzymes, and it's a rather unspecific proteolysis, the likelihood of resistance developing over time is very low, because the fungus has to mutate heavily in order to overcome the resistance that we get by overexpressing Nepentacin.
Wonderful, marvelous innovation. I wanted to check in with you if you could perhaps explain a bit more about what are the specific environmental and perhaps health benefits that arise from reducing fungicide usage through your technology.
Yes, of course, when you don't spray with fungicides, of course you lower the footprint of agriculture, the climate footprint. And that, of course, protects biodiversity. It improves the drinking water. It also increases the food safety, because when you have plants that are inherently resistant to fungal infections, then you have a more stable food production. From a health perspective, you can also see that when you have fungal infections in agriculture, these fungus that infect, they produce mycotoxins. And these mycotoxins are very toxic compounds, and they're toxic to humans and also to animals. And if we look at the world's production of crops, then up to 25% of the crops that we produce are contaminated with mycotoxins. And there are some serious health consequences of these mycotoxins. So we can remove all the mycotoxins from the food chain. But we can also lower the likelihood of fungal resistance or resistant fungus developing over time. So right now in Europe, there is an increasing problem with some of the fungus that infect us and also animals, that we cannot treat those fungal infections because the fungus have developed resistance, and that is due to the fungicides that we have used in agriculture, because they are from the same chemical family as the medicines that we use to treat fungal infections in humans and also animals. So when we lower the amount of fungicides we use, and we can do that by our technology, then we can slow or even prevent the rise in these resistant strains. And that ensures that we have effective antifungal treatments in the future.
Great. I hear there are a lot of benefits seen from various and different angles. Thank you so much, Pernille, and good luck with your company.
Thank you very much, Marcel.